So our sample problem has a car with an initial velocity of 10.0 meters per second north, accelerates at 10 meters per second squared north for 10 seconds. We are to find the final velocity after 10 seconds for A. So what do we know? Okay, so we know acceleration, and that's 10.0 meters per second squared. We also need to write north because we're doing acceleration and we have a direction. Okay?
V1.
I know V1, good. It's also 10 meters per second, and it's also going north. What else do I know? Time. And that one's in seconds, which is good because now all of our items are in seconds, right? Yep. And the two are both have meters, so there's nothing that we have to convert, which is something that you need to watch for. Okay? The first thing is asking me to find the final velocity. Okay, my final velocity would be V1 or V2, or sorry, V2 or VF.
What is this for this problem?
Yeah, the sample problem there with the car. So, which formula with those in the square rectangle ones that we use would you use to find final velocity?
V1 plus A times delta T.
Now, I don't know if you guys have noticed, but I usually make my T kind of curved. I know it kind of looks weird, but that's so that I remember that it's a T and not a plus sign. Is to help myself to identify it differently. Okay? So now we're just going to plug those numbers in, right?
Yeah.
So I'm going to have that 10.0 meters per second north plus my 10.0 meters per second squared, also going north, multiplied by my 10 seconds. 110 what?
Meters per second north.
Meters per second north. Good.
There's only 4 different dimensions.
There's a few different. Wait, no.
This is ready.
Yeah.
Okay. So, pretty straightforward, right? Just know what they are and you plug them into the formula. Okay, so the next one, Zach said this equation here. Okay, so we're going to plug those numbers in.
I need that. Why would you get there? Are you guys done? Was that from your? Are you guys done all?
Okay.
This being done.
Should be 600.
Yeah, I got 600. I don't know how you got 600.
Okay, so 10 and 10 is like 100, right? And then you have 10 squared multiplied by 10 divided by 2, so you should get 500.
I'm going to finish writing this out.
Seconds. Okay, so what do I know?
Your velocity.
I know my velocities, initial and final. My initial is what?
4 meters per second.
Okay.
You also know time. Just 5 seconds.
Time.
Never told me for acceleration.
Okay. I have one thing though.
Does it stop on the hill or does it go over the hill?
It's going over. If we read the question, it says up and down.
Yeah, I thought that's teaching a hill goes up, stops, and goes down.
Oh, I see what you're saying. I would assume that it's going over, but it doesn't actually say one way or the other. No, it goes up the hill and down the hill. I don't know. I would assume that it's going over, but that's a good question. I can't say for what.
So then it wouldn't be slowing down from 4 meters at all. It'd be 4 meters.
Well, there is a problem with this. We are given a direction, right? We are given up and down. So most of the time, this is what you do. Actually, I should almost say all the time, but we assume up, positive, down is negative.
So that should be 4 minus -6.
So we should have +4 -6
But then it should
to
be,
give it a direction.
then when you do it, isn't it, thing is it V1 minus V or plus?
No, so that's the thing, that's the thing right here.
Oh, yeah.
Okay, so my equation for acceleration is like this, right?
No.
Change in velocity divided by change in time. Gentlemen, would you prefer to leave because the rest of them seem to be following along and I don't have to talk over them? Yes, we'll tell each other a bit later.
Here, I'll tell you later.
Okay, change in your velocity. Gonna be your V2 minus V1. So you're gonna have your minus 6.0 meters per second minus a positive 4.0 meters per second divided by your time of 5.0 seconds. Okay?
What the heck's that thing right there? Just like -6 meters per second and it's on the line.
Minus
Meters
a
per
positive
second
4.
Minus positive 4.
So you could just get rid of the positive. If you want, right? To make it less confusing.
No, you need the well, you need to write it, not
Yeah.
write that. Yeah, you wouldn't have to. Okay, so
But in some
then,
cases, it will be negative.
But in some cases, it's
okay,
really full.
so now remember how we just go minus plus, right? So I'm going to have -6 plus -4, which is
-10
-10
over 12 is equal
to 2, right?
to -2 meters.
So I'm going to have -10 meters per second divided by my 5.0 seconds, which is going to have my -2 meters per second squared. Now, if I said -2 meters per second squared, what is that really in direction?
Just 2.
2 meters per second squared
The other way
Backwards, seconds, meters,
down.
seconds.
So you actually have to write down. Meters per second down.
From here, which some of you probably already started working on, this displacement part of the question. Okay, we're going to again have plus 4.0 meters per second plus negative 6.0 meters per second multiplied by that 5.0 seconds all divided by 2.
Okay, so everything's still for the
This is now me.
Very nice. Figured out. Good.
Good done.
In the field.
We should make a little